Hello everyone, this is Dr. M. Madhu Feresi, Associate Professor in the Department of Computer Science and Engineering in St. Martin's Engineering College. Welcome you all for this video lecture. I am here going to present a topic on projection and its steps. This topic comes under the subject called computer graphics. Before going to this video, we can see a short note on this computer graphics. So what is computer graphics? Computer graphics is nothing but it is the creating and manipulating of the images using programming languages. Okay, nowadays this computer languages is becoming playing a very important role in the various applications such as video games, and we are using entertainment, education, and also we are using for technical drawings, paintings, and various software tools also we are using in computer graphics for animation related work. Okay, and day-to-day life we are using in video games. All the students are using video games. Okay, so this computer graphics are of two types. One is interactive computer graphics and non-interactive computer graphics. Interactive computer graphics is what the user has a control to work on the graphics. But in non-interactive computer graphics, user does not have a work on the graphics. Okay, and this computer graphics are of two types of dimensions. One is 2-dimension and 3 dimensions. Already know about this 2D and 3D. Okay, many animation movies are common, 2Ds, 3D images or there like that. So what are the main differences between 2Ds and 3Ds? In 2D, we have this rectangle, square, these shapes are comes under 2D, 2-dimensional images. Okay, and the cuboid, pyramid, all those are comes under the 3-dimensional images. So what is the main differences here? In 2-dimensional images, that is only length and width. Okay, that is we are working on this only XY axis. But in 3D, we have length, width as well as height. It is on XY plane, XY Z plane or that. Okay, this is the main differences. In the 2D, we have XY plane, XY axis, and in 3D, we have XY Z axis. Okay, but our topic is projection. This projection is mainly used in this 3D concept only. Okay, so while the 2D object we are viewing in view plane, that time what happens, the 2D object itself we can view it. But the 3D objects we are viewing in the view plane, we are getting the 2D objects. Okay, so see. So our topic is projection. So what is projection first of all? Projection is nothing but it is the conversion of 3D object into 2D object. That is called projection. We have 3D object. While you viewing in a view plane, the 3D object is transforming many projection lines. That lines touches the view plane, and that view plane shows the 2D object, 2D plane. Okay, that is called as a projection. So see here, projection is a technique or process is used to transform the 3D object in a 2D plane. That is called projection. Okay, so for example, see here, here we have the axis. In 3D, we have an axis. So now in 2D you have only x-axis, y-axis, like this you have images. So axes are drawn on this 2 axes, but in 3D we have x, y and z. X, y and z. So here only the objects are created. 2D objects means sphere, square, rectangles, or all comes the 2D objects. And 3D objects means polygons and cuboids, pyramids. So these are the 3D objects. Okay. And these projections are of two types. One is parallel projection and the one is perspective projection. Okay. So what is parallel projection? I'll go down a small diagram. So before that, I'll show the 2D conversion of images. So here this is a video where we are showing a demo on the 2D. So I say that it's a 3D object. Okay, so these are the 3D view planes. View planes also called as the projection planes. Okay, while this 3D object have many surfaces we have. These surfaces while we are seeing in the view plane is showing the different view plane images there. That is front view, back view, top view. The surfaces views will be displayed on the view plane. That is called 2D and 3D view. And this is the main diagram for perspective projections and parallel projection. I say these projections are of two types. One is parallel projections and perspective projections. Okay, we can go for the detail about this one. Okay, so I said projections are of two types. One is parallel and perspective. So see, parallel and perspective. So in parallel projections, we have an object. So I said that this is an object. So this is the 3D object that is called polygon surface. It contains a lot of surfaces, and here we have a view plane. Okay. In parallel projections, what happened? The 3D objects transforms through the view plane along the parallel axis. Okay. So only parallel lines will be along the parallel lines. The view planes will be created. So what is parallel projection? The 3D object transforms to the view plane along parallel axis. Okay, so this is the view plane. So now what happened? The surfaces of this plane will be viewed here. Clear? So this is the image you will get on the view plane. So but the lines, the parallel lines will be go there. So here this part is called as the COP. COP is called as the center of projections. Clear? So center of projection. So here the lines are parallel and here center of projection is not occurred. So what is center of projection means? If the lines are meet at a common point. Okay. So this is called as a center of projection. Center of projection COP also can say it. Okay. So in parallel lines we don't have center of projections. The center of projections will be infinity. Okay, but in perspective projections, what happens in perspective projections? All the lines, the parallel lines, in parallel lines it is in parallel, but in perspective projection it is not in parallel. All the lines are meet in a single point called as the center of projection. Clear? Okay, so all are meet at a single point center of projection. But here in parallel projection, there is no center of projection. The center of projection is infinity. But in perspective projection, the center of projections will be finite. Okay, and also see here the length of the object. The length of the object here it is same in parallel projections. So see whatever we are having, that length will be same. But here the length of there will be a variation in the length in perspective projection. Okay, we will go for the slide in detail.
While you're shifting, talk something.
So I said that there are two types of projection. One is parallel projection and one is perspective projection. Okay. So see this one. What is parallel projection? See this diagram here. I said that now you're taking a line. One small line you're taking. That is line segment you're taking. AB is one of the object. Consider that this is an object. Now this object you are moving to the view plane. Then what happened? We are getting as A dash B dash. Okay, and it transforms along parallel lines. It transforms along parallel lines. So I said that the center of projection is not present. That is infinity. I said that. So it is infinity, and this box, this one is nothing but is a projection line or parallel. or you can say it as a view plane also. Projection plane or view plane, and the lines which is coming here, parallel lines, that is called as the projectors or projection lines. Okay. So in parallel projections, you have a object. If you while it transforms to the object to the view plane, you are getting a view plane, you are getting a object that is the same length you have. No changes happen in the length also. Okay. So see here the parallel projection, the distance of the object projection plane from the center of projection is infinity. That is one point. And here we can specify the direction of the projection instead of the center of the projection. See here this one and this object length will be similar. Some slight variation will be there, but the length will be same. Okay, and also see here the parallel projections eliminates the z coordinates. It eliminates the z coordinates. Okay, so we are converting the plane into. Okay, see. We are converting 3D object into 2D plane. Is it? So what happened? So we eliminate this We are eliminating the z axis. Okay, so because in xy plane we have only xy axis, we don't have a z plane. Clear? So we are eliminating the z coordinate systems. Okay, so you know now you are thorough about the parallel projections. The next one is, come to the next one. This is the another object. Considering this object, this is an object, these are the projection lines and these are the projectors, and here the COP is infinity. That is called parallel projections. Clear? And the next one will go, what are the characteristics of these parallel projections? So parallel projections are parallel in each other. The lines which is coming from the parallel lines, that will be parallel. So they won't intersect with each other. That is one of the characteristics. And there is a least amount of distortions with an object. So I say that object, whatever object we are viewing, that object will be, length will be same. That is no some changes. Some light distortions will be occurs in the parallel projection. And also here the view of parallel is less realistic cost. So the realistic cost of the object will be less. We have less realistic view, okay, and here we can get the good for accurate measures. Whatever he is saying, that object will be of the same length, so that can say the accuracy of the object will be good. Okay, so these are the main characteristics of the parallel projection. And this parallel projections are of two types. Clear? So what are the two types? First one is orthographic projection, and another one is orthographic projection, and the one is oblique projections. These are the two types of. Now we talk about what parallel projections and perspective projections. Now these parallel projections are of two types. One is orthographic and the one is oblique. So these are the two types of parallel projections. So this orthographic are of two types. One is multi-view and the one is axonometric. Okay, so this oblique are of two types. One is cabinet and the one is cavalier. Okay, so these are the many difference of projections. So our topic is projection and its types. We know what is projection and what are the types of projections. Orthographic means what? These all comes under the parallel projections. Parallel projections types. Okay, orthographic parallel projections and oblique parallel projections. Orthographic parallel projections means while the lines, the plane lines, the lines are coming up from the object, 3D object, the lines of projections will be touches on the view plane. That should be perpendicular. So what is orthographic projection? All lines will be perpendicular to the view plane. That is called as the orthographic projections. Okay, all lines will be perpendicular to view plane. And here oblique means it is not perpendicular view plane, is called as the oblique projections, oblique parallel projections. These are the two important types of the parallel projections. So this orthographic projection. So for example, you see here, I have drawn the diagram. So this is the object we are drawing. Okay, now you have a view plane. Now these are the position lines are coming here, and here you are creating one view plane is created here. Okay, one plane is created here. Okay, so this projection line and the view plane will be perpendicular. Okay, so in that case, if the projection lines and is perpendicular to view plane, then it is called as the orthographic projections. Okay, so listen. So this orthographic projections are of two types. One is multi-view and axonometrics. In multi-view world, so we have an object. We have different views you are viewing here. So like this, it is the front view, and again you will get one top view. So in top view also you have some plane will be there. Okay, like this is the top view plane, and then you have next side view also will be there. Okay, and planes will be created. So there are different views of images will be created while you viewing the 3D object in a 2D plane. Okay, so if you're getting more views, then it is called as a multi-view. What is multi-view? Which consists of front view, side view, and also top view. So all those views are viewed, then it is called as a multi-view. And what is axonometric? Axonometric is nothing but here there are three types of axonometrics. One is isometric, and next diametric, and next trimetric. Okay, so these three are the different types of axonometric. So axonometric is mainly depends upon the angle. Okay, so in isometric what happens? So you have an object. Thus we are taking only the simple example called polygon. Polygon is one of the 3D surfaces. Already you know about that. So this here, if the angles. So isometric means what? The angles of the coordinate system. So in angle means you have x coordinate, y coordinate, z coordinate. 3 dimensions you will have 3 coordinates will be there. So in isometric, the angles. So here you have an angles. Okay, the angles of the two coordinate systems will be of 120 degree. So will be of 120 degree. Okay, so that is called as the isometric. So have an angle in the 3D object. That angles will be of 120 degree. But in diametric what happens? All the angle sides will be of 120, equal size. So here you have an angle, here you have an angle, here you have different angles will be there. So all the angle length will be of equal, that is equal to 120 degree. Okay, and what is diametric? Diametric here in the object, only two sides of angles will be of equal length and one side will be of different length, different angles. So that is called the diametric. So here, this is an object. So in this object, only this and this will be of equal and this will be not equal. Okay, so in that case that is called as the diametric orthographic projections. And trimetric means all angles will not be equal. The lines which is projected from that will not be equal to the equal. So in that case that is called trimetric. So these are the different types of parallel projections. Okay, so now you know what is parallel projection, what is orthographic projection, what is multi-view, and what is axonometric. And under axonometric, what is isometric, diametric, and trimetric. These are the different types of parallel projections. Okay, this parallel projections or another type also I say that it is oblique. What is oblique? Oblique is not perpendicular to the viewplane. Okay, so in the case it is parallel lines. The parallel lines it is coming from the object which is perpendicular to 90 degree. Okay, if suppose you have an object like this. Okay, so here you have an object. So the lines are not perpendicular, like this you are flowing. Okay, viewplane is like this. In this case, it is not perpendicular. So that types of projections are called as the oblique parallel projections. But lines are parallel, but the angle of the projection lines and the view planes are not perpendicular. In that case, that is called as the oblique projections. So these oblique projections are of two types. One is cabinet and one is cavalier. So here the angle only will be changed. What is angle? So in the cavalier, the angle will be of 45 degree. Okay, 45 degree, and next here the cabinet will be of 90 degree. Okay, so 63.4 degree. Okay, so here the angle will be. So go for the PPT. So now we talk about what is parallel projection, what is oblique projection, what is orthographic projection, and then we have seen about the okay, so parallel projection, orthographic projection. See here, I said about the parallel projection types. Okay, so multi-view, top view, five view. These are the different types of projections. I said that, and it's about the axonometric, isometric. Axonometric connect three types. Isometric. So these are the angles will of equal size. And next it is diametric. Only two angles will be equal. One is unequal. and next one is trimetric, all things are unequal. Okay, and these are some of the examples of diametric, trimetric and isometric. Okay, and here occupation, what I say, this is not perpendicular to view plane. Okay. So see that here it is not perpendicular, and see, all angles are equal, and here it is diametric, two angles are equal, here trimetric, three angles are different, and these are different types of images. And come to the oblique, say it is not perpendicular, so what happened here? Cavalier images of 45 degree and cabinet image of 63.4 degree. What I explained on the board. Okay, so here the main thing is it is a less realistic, we have a less realistic images. And come to the next one. These are different types of optical positions, cavalier and cabinet. Okay, and see here these are the full scale. What are the main differences? In cavalier, we have a 45 degree and the length will be no changes. But in the cabinet, we have a 63.4 degree of angle, and then there will be a variations in the length. Okay, and come to the perspective positions. What is perspective positions? I said already. So you have an object. There will be changes happen in this object while viewing through the view plane. And see here the length is more, here the object length is less, and you have a COP. The COP is nothing but center of projection, here it is finite state. Okay, so this is called perspective projections. What is that? The COP is present, the COP is at finite state, and here we have a changes happen in the length of the object also. Okay, so what is COP? COP is also called as project reference point. Here. And this is another object I'm viewing here. You take a polygon surfaces while viewing, the object will be reduces. The original length will be vary, and you have to get the center of projection point. Okay, that is called perspective projections. And these are the examples of perspective projections. What we are in the real time, we have a road. While you seeing near, the object will be big. While seeing in the far, the object will be small. So this is the example of the perspective projection. See here, the trees are here, but we are seeing a tree at last, the tree is very less, very small size. Okay, and this is called the center of projections. What we are seeing here, this is the center of projections. Clear? And these are the characteristics. What you say, it is finite state, and it is very difficult to use. And also here the size and shape will be changed. And here the varnishing concept is this. Varnishing point means that all the lines are made at a single point is called the varnishing point. Clear? And this projection is look like a realistic view. Clear? And the varnishing point, what I said. So see here, varnishing point means it is a point in an image where the parallel lines are interlinked. All the lines are coming to form a single point, that is called as a varnishing point. We are using this perspective in 3D games, and also we are using in graphics editor, and also we are using this one in the background, shadow effect, everywhere we are using. There are three types of varnishing point. One is 1 point, 2 point, 3 point. 1 point means there will be a one varnishing point will be there. That is called 1 point varnishing point. We are using more in railway tracks and roads, buildings, everywhere we are using. And next one is, this is the example of 1 point projection varnishing point. And next one is 2 point projection is also called an angular perspective. Here we are using two varnishing point here. See here, two varnishing point we are using here. Mainly we are using in the corner road. Okay, in that example we are using this projection we look in the corner road. And this is the example of 2 point projection. This corner gate also, like gate loop. And next, this is the third point perspective projections. We have a three varnishing point, 1, 2 and 3. Mainly we are using this for skyscraper. Skyscraping is nothing but it is a tall building which have more number of floors. So this is the example of the 3 point perspective projection. Okay, we have a 3 varnishing point here. Yeah. And next, these are the advantages. This perspective projections is a very good realistic view, and also it looks better, and also but it is difficult to draw also. This is the example of parallel projection, and this is the example of perspective projections. And this is the overall view of this types. I said Panel partitions are of different types, parallel, perspective, and orthographic, oblique are the types, and said multi-view and axiomatic are the types of orthographic, and axiomatic of isometric, diametric, trimetric. I said that the oblique are of two types, one is cavalier and cabinet, and like perspective are of three types, 1 point, 2 point, 3 point. Clear? Okay, so these are the main differences already informed you. Already have played the video. And panel projections is a different way. So what is the main differences is in the panel projection, the object what we are seeing that is same what we are looking as a telescope. But in perspective, it looks like a three-dimensional object. And here we have using the object which is far away is smaller, it is here it is bigger. But in panel projections we are not using these types of things. Okay, this effects will not be occurred here. And here in panel projection it is infinite and it is finite there. Already we have seen these differences also. And in panel projections we get the accurate view of an object, but there we are not getting an accurate view. Clear? And here the lines of parallels are in parallel, but in perspective projections we are not going, the lines will not be in parallel. And here the COP is not present, but that is COP is present. COP is center of projections. And here these are the two types we have seen already, orthographic and oblique. Here the 1 point, 2 point, 3 point are the types of projections. Okay? And at last, this parallel projections are not form the realistic view, but this perspective will form the realistic view. So what you have seen in this lecture, you have seen what is projection. First of all, what is projection? And you have seen projection types. There are two types, orthographic and oblique. And orthographic are of two types, multi-view and axiomatic. Axiomatic are of three types, one is isometric, diametric and trimetric. And oblique are of two types, one is cabinet and cavalier. Okay, and perspective are of three types, one is 1 point, 2 point and 3 point vanishing point. So these are the different types of projections. Clear? So mainly we are using these projections in the technical drawing for engineers, architectures, all are using this projections only for drawing purposes. And also this projections are mainly used for constructing buildings. Everywhere we are using these projections. So these are the important topics in computer graphics. Okay, and then these are the. Okay, now you have understood what is projection, what are those things. And main thing is here we have mainly using this one in a real time, what we have seen the objects in the real veranda. So like that we have seen, we are using more on the perspective only. This perspective is look like a real objects. Okay, real view. What we are looking the object will look like a real view, but compared to the parallel. Okay, parallel projections. And orthographic oblique we are using in engineering drawings. Already have using these types of projections, engineering drawing, engineering graphics. Okay, but we are implementing this related in the computer graphics with the help of programming languages. Okay, you have no using your computer graphics using C language, Java, like that you can implement these concepts, projection concepts using different platforms. Clear?